in Excel, we have the data for time versus temperature, and I went ahead and labeled above the columns, time is in seconds and temperatures in degrees Celsius. So I want to plot this data. Ugh. So I'm going to select it, both columns, and then I'm going to go to Insert, and I want a graph. Not a giant fan of Excel's graphs these days. Data. We want to give the graph a title. So this is the data for the reaction of magnesium solid and aqueous hydrochloric acid. So our graph has a title. We would, of course, in written form, add more like a formal title in text and refer to it in the narrative. Then we also need to title our axes. So if you select the graph in Excel and there's this little plus thing, if you'll click on that, you've got some choices. So what we want, what I'm going to do now is axis titles. So do you see how when I select that, it pops up axis title? You can unselect it and they'll go away. So don't be fearful that you'll like click the wrong thing and need to, you can always unclick it. I don't know. So when we title our axes, the best titles tell what's graphed, the unit, and the associated uncertainty. So on our y-axis, what do we have? Temperature. You monitored every second. I would say plus or minus 1 second. So our temperature, and then it's in, you can write this, you can go ahead and put degrees Celsius, then the uncertainty, or you can just put plus or minus 0.1 degrees Celsius. So that's what I'm going to do. Plus or minus 0.1. Now, the degree symbol, you'll go to Insert, Symbol, Symbol, and we're going to come back to this because we'll need the plus or minus. I'm actually just going to do both now. So I'm going to do click Insert, select plus or minus, click Insert, click Close. What?
You only have 3 people in here.
There you go. Okay. So actually I put it in the wrong place. So I'm going to put the plus or minus here. So symbol, symbol, plus or minus. So my temperature is in degrees Celsius and the uncertainty is plus or minus 1. Then what am I plotting on the x-axis? Time. So plus or minus 1 second. Do we agree? Then what we want to do for this graph is make sure we don't have like extra space. We want to maximize our use of the graph area. So we're going to change the range. This one, I don't know what it is. Half the time I can't get the right thing to pop up. So I'm going to make the range of the y-axis a little smaller. I think 60 is probably a good high end of the range, but on the low end, I'm going to say 20. What do we think? Yeah? So now we need to use Excel to fit our data. Here's where it's not I like being able to use Excel. I don't like the way you have to do it. In the past, you could select the range of data that you wanted to fit. Like you could select it in the number form and linearly do a linear regression and fit that data. Now with Excel, you have to plot the data and fit it that way. So what we want to do is look at our data, and I think we're going to want to do around, let's see, we want to take the maximum temperature that we recorded, and then when it starts to decrease. So I'm going to start looking around 300 seconds. Do you see if I cursor over it, that just gives me an idea. So I'm going to scroll down. Okay, so we've got 56. Is 56.9 the highest you think you recorded? Okay, so I'm going to try to find where, like the first time we saw that, and go from there. I mean, listen, yeah, listen, it's fine. So what I like to do, for me, I'm a visual person, so it helps me to change colors of the data because of how silly this is. So what I'm going to do, I'm going to start selecting the data at that first place that I see, first place I think I see, the 56.9, and I'm going to select everything past that. So this is the highest temperature, and then the temperature's decreasing, right? Which is what the data that I want to fit with a linear fit and then use as my regression. Select, select, select. So much selecting. Okay. Now, for me, I'm going to change the color to red just so I remind myself visually that I did that. Then I have to graph this to fit the data. Wowza, what happened? I don't like the look of this. What? Oh, it does. Okay. Whew. I'm going to do the same graph again. It's going to look, not as silly as they have before. This one, I don't care if you put this in. Really, you'd put elaborate Excel, is kind of silly. What we need, I'm going to go ahead, I'm going to move this up. Just so we're not way, 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 way down. I'm going to put it right here. Before I forget, can I get from you guys the mass of magnesium solid? 101.1. 1.0. Did I type that right? And I'm going to put the uncertainty in a separate cell because I'm going to use this. I like using Excel to do my math for me. Okay. And then what about volume of HCl? What was it? 100.0. So I'm going to go format cells. I selected that cell that was not keeping up with my significant figures. I'm going to go to number, number, and include one decimal place. Okay. So here the heck. So for this one, watch this. This is the data that I want the best fit line for. So go back to the line. There's a pick line, then I go to more options. I need to actually see the formula. Linear fit. Make sure you don't select anything else. I need to see the equation. And if you're interested in the r squared, that's pretty good. I'm going to delete the r squared though. Go away. Well, because I'm going to copy and paste. Yes. So I'm going to copy this. Here. So, what's my starting temperature? You can average those, or I'm going to go 22.4. That's 23, some 22.3. So now I need to use this equation. So I need to figure out what time I added my reaction mixture, added my solid in this case. So I would say right here, 120 seconds. Do you see how it jumps and then starts to go up? That's how I detect it. You can do 119 or 120. What do you think? Huh?
It went up a lot. Let's say 120.
What'd you say?
Let's do 120.
Okay.
It went up a lot.
It did. So what we're going to do, we know our initial temperature. That's that equilibrated temperature of our hydrochloric acid before the reaction started. What we're going to do now is take our linear fit and extrapolate to find the maximum. He must not like hearing me talk. The maximum temperature had our reaction happened instantaneously to help us correct for what? Heat lost. So Y is temperature and X is time. I sometimes like to just, I know that's not beautiful, but it just helps my brain. So the time that I'm going to plug in is what? What do you guys say? 120. So Excel, let it do the work for you. I'm going to type an equal sign, which means Excel is going to math what I type after the equal sign for me. I'm going to do equals and then just plug in negative, and you could copy and paste this. I'm going to type it. Negative 0.01 times 120 seconds plus 60.52. And that's going to give me the what? Maximum temperature. Now, that has too many significant figures in it, right? Right-click on the cell, go Format Cell, number, and then put how many decimal places it needs. I can only measure to the tens place, so I'm gonna say 1 decimal place. Now you could round it, but you can let Excel do it for you. The uncertainty, I'm keeping the uncertainty in a separate cell, so that way I can math with it more easily. Okay, fair? So how am I gonna find my change in temperature? Okay, so watch this. Equals, select that cell, minus that cell. Now what's the uncertainty here gonna be? Is it gonna still be 0.1? When you add or subtract, you add the absolute uncertainties, right? So it's gonna be plus or minus 1. Now what? What? You need to go back and do this in Excel. I'll send you the data.
Use the computer for it.
Yes. You need to practice with Excel. Stop, don't take pictures. I mean, you can. You need to practice doing this. Okay, so now what can I do? I'm gonna leave you at this next part because the rest of it you know how to do.
Can you use that equation?
So we can use the Q of water, since most of the hydrochloric acid was water, and find the heat absorbed by the water, right? Then how is that related to the energy? What is that gonna, then what?
Then
Eh?
we use the we would subtract that from the energy that we got here in total. When we add it to the energy, we'd add the Q of water, the energy absorbed by the water, to our energy.
What is your energy?
Oh wait, we'd anyway.
Mm-hmm.
I confuse temperature and energy.
What are you gonna do?
Use the data calculator?
Huh?
Use the data calculator?
No? This is calorimetry. So you're gonna have the heat absorbed, the heat energy absorbed by the water. How does that relate to the heat energy evolved by the reaction taking place in water?
Is it negative?
Equal and opposite, so you switch the sign. Then what do you need to divide by?
Water thing?
No. Now it's from the perspective of the magnesium solid reacting with hydrochloric acid, once you flip the sign.
Okay, so we do.
But that's just in joules or kilojoules, depending on how you work it out. We need to report it in what? Okay, how are you gonna figure out moles? Of what?
You still talking online?
Uh-huh, I'm recording.
You're recording?
Yeah.
Okay, well, I need to show you the most annoying way to turn stuff in on Kidum whenever you get a chance.
Okay, I'll be over there in just a second. Kilojoules per mole of what?
Something.
Which one? You can be circumspect and just say something generally. Nope.
Magnesium in the product?
Nope. That's the amount of energy produced.
Oh, by the combustion?
No, you've got a long ways before you can figure out the enthalpy of combustion. Because you're going to have to go through the same process for the magnesium oxide data. Look back at your notes.